Hello everybody, so this is again Dr. Sergey Sarkisov, okay? And what we're going to do is we're going to discuss or talk about or learn some combinatorics, okay? So mathematics, one of my favorite fields is combinatorics. Now, let me underline this, it's very important. And what I'm talking about here, we're going to do a few things. We'll talk about permutations, okay? Permutations. We'll talk about combinations, and then we can do a few things with that. There's a binomial expansion that we can talk about. We can talk about probability, right? So there are a lot of topics and a lot of things that can be addressed with some of this knowledge, the fundamental things we'll do here today. Okay, so let's talk about specifically a few topics of permutations, and before we do probability or binomial theorem, anything like that, permutations and combinations, okay? So combinations and permutations. The only difference, okay, and I'll tell you in a bit, but the difference basically is permutations, what matters is the order matters, okay, the order matters. Okay, so let's say the order here matters, for example, when you're talking about letters and words, right? When you have a word, right, like let's say the word dog. If you spell it backwards, the word is God, right? Those are three letters. They're the same letters, D-O-G, G-O-D, it's the same set of letters. Combinations would not care about the order. So for example, for combinations, dog and God, like those three letters, D-O-G, G-O-D, you can alphabetize them as D-G-O. It's the same combination. But permutations, D-O-G and D and G-O-D, those are different. So that's the idea. Order does matter and order does not. Order doesn't matter. And then of course there are a few other things that we do in each of these categories. There's something called with and without replacement, okay? So for example, can I have like a few letters of D, right? Like for example, can I have the word like toddler, right? Toddler has T-O-D-D-L-E-R, right? Dog just has a one, like everything is one letter, D-O-G, right? Now if you say like let's say cat, C-A-T, right? But if I say kettle, K-E-T-T-L-E, for example, right? There's two E's, there's two T's. I'm allowing replacement. So there's permutations with and without replacements. There's combinations also, with and without replacements. So just an idea there that we have a lot, kind of like 4 cases to talk about versus, just the, 1 or 2. So here goes. Let me explain what in the world is permutation? What is combination? What's going on here? Okay, the idea is let's go by example. All right, so let me talk about this. Question would be, let's talk about how many. Okay, how many? Let's say we have like one of those like license plates, but let's say we're talking about only four like let's say numbers. Okay, 4 digits. So let's say you have a 4-digit number, 4 digits. Let's not even say number. And so how many permutations, how many different such numbers? And okay, replacement is allowed. For example, 1, 1, 7, 7. You can do 7 a few times. That's a number, right? That's a combination. That's a permutation. So how many can we permute these digits? If you take 4 digits, how many ways? So here you have digits, for example, maybe like a 7, a 3, an 8, and maybe a 3 again, right? Here, how many options do we have for this? How many options? We have 10 options, 10 possibilities, right? And then again, we'll have 10 possibilities for this one. And then we multiply and we have 10 possibilities for this one, we have 10 possibilities for this one, because it's number of digits, okay? Number of digits, 10 number of digits, right? And so we would get 10 to the 4th power. That's what it means, 10 to the 4th power. It means 10 times 10 times 10 times 10, 4 times, right? And so what I want to say is, you may wonder, well, why am I multiplying? Why not add 10 plus 10 plus 10? Let's actually, put some detail into this. So you have, let me show you what's going on here. You start, let's say, with the digit 0. Okay? With the digit 0, you can have 0, 0. You can have 0, 1. You can have 0, 2, 0, 3, right? And all the way to 0, 9, right? This is 10, right? 0, 1, 2, 3. There are 10 digits. So with 0, you can have 10. With 1, you're going to have 10, right? 1, 1, 1, 2, 1, 3, 1, 9. This is just if I'm talking about like just 2-digit numbers. Think about it. Okay? And we could have maybe with this, we could have maybe a 2, 0, 2, 1, 2, 2, 2, 3, right? 2, 9. And we can go on and on like this with maybe using a 9 at the end, you know, like a 90, right? So 9, 0, 9, 1, 9, 2, 9 through 3, 9, and 9 with the 9. So you see what's going on. You have 10, the first digit, 0, 1, 2, 9. There's 10 digits possible for the first one. And for each digit, there are 10 possibilities for the second. That's the idea. Hear me out here. For each first digit, there are 10 possibilities for the second digit. Hence, you know, of, like, there's 10 of the ones with the 0th digit first. 10 of them. And when you say of, you multiply. So that's where we have a 10 times 10. Now let's say the next digit, right, can be a 0. You have 100, the 10 times 10, with the 0. 100 with the next digit can be a 1. 100 with the 2. 100 with the 3. So even like say for this, for each one of these, we can have 10 possible digits. So there are 10 of each one of these. So you do times another 10 for the third digit, and times another 10 similarly for the fourth, because you can have, think about 1,000, 10 times 10 times 10, with a 0, 1,000 with a 1, 1,000 with a fourth digit being a 2. And so you have 10 of those 1,000. And that's why you get a 10,000. 10, 10, 10, 10 is 10 to the fourth power, 10,000. Okay? That's permutation with order mattering, of course, right? Because, I mean, you know, like 7383 is different than 3783. But also, you're allowed to have replacement. So this is permutations. This is permutation with replacement. Okay? Permutation. I'll tell you combinations in a little bit. With replacement. With replacement. This is that example. Okay? So, because there's permutations with the replacement, there's permutations without. What is without replacement? Okay. Without replacement, and again, another tricky thing is sometimes I may ask you, you know, how many 4-digit numbers there are? And you know what you would do? It's not 10,000. 4-digit numbers, the only difference is this one cannot be a 0. So you would have 9, kind of tricky, right? Times 10, times 10, times 10. And it's actually 90,000 4-digit numbers. Because you cannot, the first 10,000 digit numbers, or, 9,000, because the first 1,000 of them is just, 0, 999. It's not considered a 4-digit number, right? So this digit cannot be a 0. So you would have a choice from 1 to 9, that's 9. And then, of course, 0 through 9, 10, 0 through 9, 10, 0 through 9, 10. Okay, so it's interesting, right? Hopefully that makes some sense. Okay, now, so what is permutations without replacement? Well, without replacement, this is what you would do. You can do any digit, let's say 10. And then you have only 9 left. So you put times 9, right? Because you already used 1. For example, if I do a 0, I can only do 1 through 9. I cannot do any more 0, right? So if I do 0, I only have 1 through 9 left. Now let's say I do 0 and 1. Then I only have 2 through 8 left. There's 8 left. And then let's say I choose like a 0, 1, and maybe a 4. Then I only have 7 left, right? I have 2, 3, and then 5, 6, 7, 8, 9 left. So there would be 7 left. So that's the idea. That this is not okay. This is with replacement allowed. Let's do like this. So if I do maybe, let's example here. Let me kind of erase the board a little bit, give you some space here so you can see better. What if I did, and I want to really spread it out a little bit. So let's say here's an example with the same thing. How many 4-digit, let's say, numbers are there? And of course, let's say including the 0 being here is okay. So let's say I have like a 3, a 7, and a 5, and a, can I do a 5, a 7, and 3 again? Okay, let's do another digit, maybe a 2, okay? So something like this, so this is permutations without replacement, permutations. The example would be similar, but without replacement, without replacement, okay? So cannot replace, cannot have the same digit, okay? Again, and then this is what you have, of course, 10 possibilities now. We're talking about not like exact numbers, so if 0 is okay as well, okay, it's something. And then times you have 9 left, and then you have times the 8 that are left now, okay? And then finally, 7 that are finally left, okay? From the ones you can choose. Make sense? So then that would be what? some number 90. What is that? 72 times 7. Let me try this in my head. 72 times 7. 490 and 14. 504. I'm getting everyone, if you can do it, 5,040. So this will be 5,040. This is much less than this being 10,000, right? It's almost like half of that, a little bit more, but cool, right? So just interesting. As soon as you cannot replace, in other words, when is there some kind of replacement where you have the digit, the same kind of repetition, some kind of digit? It's going to be this minus that, which is going to be 4,960. Cool, right? Like basically, there's half a half. That's interesting. It's something interesting for us to look into. So now let's do combinations. This is a little bit more interesting. Okay? Combinations is like, for example, let me say a group of something, like a combination of something. For example, let's do this. So we did permutations. Let's do combinations. Combinations, it's like this. Let's say we talk about, let's do kind of 3 because it's going to be a lot. Like, so we have letters. Let's talk about letters or students. A, B, C, D. This is our sample space, okay, or something like a set, like where we have everything, where we can choose from the things we're allowed to use, which is A, B, C, D, maybe Albert, Ben, Catherine, and David. Like maybe those are the 4 people that I have sitting here right now, which, you know, you guys are different, of course. But, and we can make maybe a group of, let's do 2 people, like let's collect. Actually, you know what, I'm going to make it a little interesting more so you can understand it. Let me do 5 students, or 5, you know, A, B, C, 5 letters, and we're going to choose 3, okay? And so here what we're going to do, combinations, combinatorics, right? Combinatorics. This is basically, repetition's not allowed, because I'm not going to do Catherine and Catherine, okay? So let's just say kind of without, like right away, we're gonna do the one without. We're not going to replace. We're not going to do replacement. And if it was with replacement, that would be very much the same thing, but just order not mattering. Okay? So that would be like, the order doesn't matter. So for example, 7383 and 3783, and then that would be a little different. You would divide by something. So again, I'm not going to go to that. I'm going to specifically jump straight into without replacement combinations. It's like a double step jump, okay? Let me show you what's going on here. This is more relevant to what we'll do. Like let's say this is a question I have for you. Let's select 3, how many groups of 3 students are there from the collection of these 5 students, okay? That's what we're going to do. It's like this. It's basically I'm making, not license plates, because you know AA is 1 and ABA, but just like an example of sets. How many? Choose 3 students from these 5. These 5. Right? Like how many groups? How many such groups? How many such? And the combination group is combination. These groups we can say sets or even combination. This is where the combinations comes in. Okay. So combinations. In other words, here are examples. Ready? And I'm going to go in that order, like an A first. Okay, so let's say I choose the student A, and I'll put this in as a set for a second. And then maybe the next one I would choose B. Let's just keep it like in order, alphabetically, and then C. Oh, here's a group of students. No. And you know what I'm going to do now? I'm going to erase the braces, and I'm going to erase the commas. So here's one combination, A, B, C. Now everyone understands that if I were doing permutations without replacement, I would have A, B, C. I could have A, C, and then B. I could have B, right? I could have, look at this, B, and then A, C, B, C, A, and this is actually 3 times 2 times 1. It's the same kind of thing as here, 3 times 2 times 1, right? Because you have 3 and then 2 left and then 1 left, and so you get a CAB, and that's CBA, and that's 6. But look, again, this is the same group of students. It's the same, trio, right? It's the same, set of students, combination, group, right? So we would divide by that 3 factorial. No, factorial. What is factorial? It's 3 times 2 times 1. So we would divide by this. This is 6. We would divide by that 6 later. Okay. Now let me before we continue with this, let me talk about factorial. Just a symbol notation. Let's do this with a different color. Okay. What is factorial? Let's do it right here. Factorial means like, let's say n factorial. Factorial is like a little exclamation mark. It really is. Exclamation mark. What does it mean? It means, let's do like let me make it easy. Let's do like 7 factorial. 7 factorial, let me give an example. It means what? 7 times, what's 7 minus 1? 6, and then 1 less, times 5, times 4, times 3, times 2, times 1. It goes all the way, you know, to 1. And basically, this is the idea here that we had, look, 10, 9, 8, 7, but we stopped. Why? Because we only have 4, not 10. We're not doing 10 of those 10-digit numbers, like 10-digit numbers. We're doing it with the 10 digits. We're doing only 4-digit numbers with the 10-digit possible digit scenario, right? So what you actually have this formula here is, look, let me show you the formulas. Okay, so I have, let's do this. We have 4 digits. So 10 digits, 4-digit numbers. Make sense? So with that, you know what happens here? This is that right there. Let's put an n to it. So it would be 10 to the 4th. You see that? So if I have, let's do it in red. Let me kind of give you like an n and a k. Okay. So let's say we had 10 and 4, and we did 10 to the 4th. If you had n digits allowed, n possible, you know, digits are, you know, some collection of things, and you're choosing k of them, like for example, 4-digit numbers, k-digit numbers, you know, different ones. That's going to be n to the k power. Okay. Now, if you do here n digits, but the same thing. Okay. So n digits, but not replacement. We don't need a hyphen, so erase the hyphen. So n digits. You know, English-wise, we don't need a hyphen. So it's that. And then we have k, you know, digit, but not replacement numbers. You know what that does? It's going to be k times, so n times n minus 1 times n minus 2, and it does it k times. So you would do n minus k, look at this, minus 0, minus 1, minus 2, so k minus 1. Actually, it's kind of tricky. You have to think about that. And what that actually is, everybody, is n factorial over k factorial. You can check that out. One second, over n minus k, over n minus k factorial. Yeah. So you have k of them that you're actually having. Watch this. Let me show you how that would work. So this is our formula. Okay. This actually, you can say permutation like n k, but this is again when without replacement, and that's with replacement. Okay. But let me show you one thing. Let me erase this p, but this is sometimes written like that. But look. What I think is interesting for you to see is what's going on here. Look, if you take this 10 and 4, 10 factorial divided by 10 minus 4, right? 10 minus 4 factorial will be, that's our formula, watch this, 10 times 9 times 8 times 7 times 6. That's what factorial means. Times 5 times 4 times 3 times 2 times 1. All over, what's 10 minus 4? 6. 6 times 5 times 4 times 3 times 2 times 1. Oh, this cancels with this. And this is what we're left with. 10, 9, 8, 7. 10, 9, 8, 7. You see that? The same thing that we got. And this, of course, is 10 to the 4th. It's easier. So combinations, let me show you. How many of these are there? There are, how many? So let's say we're choosing, we're going to do, like in red. We're going to do k students from n possible. Okay? And select these groups. So if we do that, this is, think about it, this is A, B, C, okay? You can do any letter, so let's say we choose 3. How many permutations of these are there? There are 3 factorial, right? 3 times 2 times 1. So this is going to be 3, this is 6, which is equal to 3 for A, B, C, the first one, then times 2, you have 2 left, and then 1. That's going to be 3 factorial, and that's the idea of k factorial, everybody, okay? So kind of equivalent to k factorial. That's where, so that's going to be the permutations per se, okay? But we don't want, we consider this one set, but this is just one combination. That's, you know, distinct combination, one distinct different, okay? Combination, not 6. Not 6, right? Let me erase this side. This is just like exclamation mark at this point. not 6. Okay, so keep in mind, ABC, it's just Albert, Ben, and Catherine. Like, that's it. There's Catherine, Ben, and Albert are the same. These are the same. So just keep it as 1, not 6. And we're going to have to divide by this 6 later. That's what I'm trying to tell you now so you can understand. Because, again, ABC is just one thing. So let me show you what happens. Let's actually see so think about it. We could have, first of all, okay, you see how we did this in this n factorial over n minus k factorial? What we want is, and so I said 3. So we want 1, 2, 3, right, everyone? So if I did all 5 students, like trying to come, some kind of permutation, imagine permutation of 5 students, you would have 5 times 5 times 5 times 5 times 5 if replacement was mattering. Now, without replacement, combinations without replacement, right? That means we're going to do 5 times 4 times 3 times 2 times 1. Now, we don't want this because we want 5 times 4 times 3. That's what this is doing. I didn't want the other 6 digits, so I divided by the 6 factorial. You see that? And this is difficult. I'm not saying this is easy. To teach it is difficult. To learn it is even more. I mean, it's both ways difficult. I remember it took me years to really grasp this. Okay? So I'm showing you. I've taught it a few times, and I think hopefully, you're going to grasp some of this idea. But combinatorics, this combination, why is it this? There's something called choose, and like, why is it going to be 5 choose 3? Why does that give you the number of groups? Like, I want you to get the depth of that, right? That's what I'm trying to get to. Okay, so watch this. Why is it not just like random number? Why is it 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1, 2 times 1? Like, why is it like that? Why do I know right away it's 5 times 4 over 2? I know it's 10. I know the answer to this is 10. I know it. But how do you know it? How do you know it soon enough, quickly? Let me show you. So because of this is where the idea comes from of 5 factorial. You see that right there? You see that's the same right there, that thing. Over 5 minus, now we're not using 2, right? So we're using 3. So we're not using 2. So we're going to divide by 2 factorial, which is the same thing as 5 minus the 3 factorial. That's where that comes from, right there. Huh? Okay, that's there. That's so because we're using. I want to select 3. I don't want to select all 5 students because selecting all 5 is that's just one possibility. And actually, that's interesting why it is the case. But look, so instead of 5, 4, 3, 2, 1, I'm going to do 5, 4, 3. Okay? Now, when we get that, we also all of this will be considered different, and we don't want that. So we will divide by this. This is k factorial. So by 3 factorial, you would do that, everyone. Because you have 6 of everything, and you want just 1 of that everything. In other words, you have ABC. This is going to be all different, and you're like, you know what? All of these 6 are the same thing. Let me divide 6 by 6 to get to just a 1. That's where that 6 division by the 6 comes in. Okay? So that is what's going on. But let me explain a little bit more in depth. So watch. If I did A, B, C, okay? And again, I could do, like I'm no replacement now. So 5, 4, 3, not 5, 5, 5. Okay? So maybe now I'll get A, C, B. This is where the division by 6 right there comes in. This division by 2 factorial, this is 2 factorial, it's just the fact that we're doing 3 people, not 5. We forget those 2 blanks. That's this. Forget that the order mattered. Let's say that order does not matter, right? That means that this is like, all of these are one thing. Don't do this. That's dividing by the 6 factorial. So what are the possibilities? Let's write them out now. Yeah, taking Albert, Ben, and Catherine, that's one set. Now maybe A with Beth, Albert with Beth, with maybe David, and maybe with, I don't know, what would I say, Edward or Edgar. So maybe A with B with E. Those are the only possibilities, right? If Albert and Ben are in the group, you can only have C, D, E. A, B with C, A, B with D, A, B with E. Now watch this. You can have Ben or B with, you cannot have A anymore. That's the thing, because that's where that comes in. Because if you had B with A, you see, like that would be, that's the 6 of them instead of just 1 of them, right? So this is where that idea that you're going to divide by this will, yeah, we already said this is just 1 and not 6, so divide by. We're going to divide by this. This is where that is right there. Divide out by the 3, which is 3 factorial, right? Okay, that's the idea there. So that's where that comes from. So anyway, let me show you. Yeah. So now let's say we no more a, because a that's where a is going. Albert's going to be. If you have a, well, hold up, wait. You can also have without Ben Albert, right? So maybe a with C, and then you can have maybe D, or A with C, and you can have only E. That's the only option with A and C. And maybe A with D, but not B and C, and then E, right? Make sense? Those are the only possibilities with Albert being there. Now let's say Albert or A is not there. Well, we can do B, and then with C and D. B with C and E, okay? And what else? We can do B. Let me kind of make sure we can have some space there. Let me just erase this, everybody. You've seen it though, so that's good. And then you can have now B with D and no C, and then E. And then that's the only options left is no more B and no more A, so you have C, D, and E. And if you do see this, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember I told you, I'm feeling it's 10. I know it's 10. I didn't like remember the answer's 10. I kind of, I did it in my head. Let me show you what I did. There are 10 possibilities. And 10, right, is equal to what? 5 factorial. You see what I did there? Over 5 minus, let me actually write it just how would we think initially. So 5 factorial over, let me actually, what you were thinking is 5 times 4 times 3 over the 6, right? Because you don't want, again, you don't want to count them all as 5, 4 times 3. That's all different. The order does matter. So without order mattering, you would divide by the 6. Remember, because the 6, each of those 6 is just 1. But really what this is 5 times 4 times 3 times 2 times 1 all over the 2 times 1, right? Because we really didn't have, that's what that is. And 6 is what? 3 times 2 times 1. That's where the 6 really came from. Okay, so, and then that's what's going on there. And so you can actually say, you know what, it's 5 factorial over 3 factorial, 5 minus 3, that's what 2 is factorial, okay? See that, everybody? And that's going to be something called 5 choose. So 5 choose 3, or 3, choose 3 from 5. You can, sometimes people do 3 choose 5, some people do 5 choose 3. But you're choosing 3 from 5, so choose 3 from 5, and that can be written as 5 choose 3. That's why it's notation for combinations, choosing. So we have, when I say give me 3 students from a group of 5 students, how many such triplets are there? It's 5 choose 3. And let me show you, does this even work out? 5 times 4 times 3, oh, that's 60 over 6, yes, it's 10. Make sure you check that, like this is equal to that, right? 20 times 3, 60 over 6, 10, yeah. Cool, right? So now, let me ask you, just kind of, let's finalize the lesson, at least this portion of the video, at this one more time. Let's do this. Let's say I ask you the question, how many handshakes? Like, so everyone in this class is going to shake hands. Let's say, how many handshakes? And everybody, we have about 30 students. How many handshakes will take place? Like, everyone's going to shake hands. Okay, so just, I'm not going to write that. In our class of 29 students, let's say, I'm going to make it up, just kind of an easy number. Let's even do 30 students and one, myself. I want to shake hands with y'all too, I'm going to be friendly. So, and one professor, students. So, 30 students and me and myself. So 31, right? It's kind of tricky, but 30, 31. But so we're going to be having 31 people. We have to shake hands with each one. That's what is a handshake? It's basically how many pairs of us can we select, right? For example, here's the trick. So you would think, okay, 30, 31 people, 31, n is 31, right? And k is equal to 2. So yeah, if you do the formula, it's actually going to be, the number is going to be 31, choose 2, and you can do the formula. 31 factorial, oops, 31 factorial over 2 factorial. And what's 31 minus 2? 29 factorial, da 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 da. That's, think about that. That's 31, 30, da 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 da. So what's this? 31 times 30 times 29 times 28 times 27. And then all over 2 times 1 times 29 times 28 times 27. Da, da, da. These will cancel. You see that? And what's 31 times 30 over 2 times 1? And this is also this 29 over there, right? That's going to be 15 times 31, or that's going to be, what is that, 930 divided by 2, 465. Let me see that fits on the board. 465. Wow, right? We have to do 465 handshakes. Like, really? If we want to shake hands, everybody shakes hands with everybody. And let's say it's just like, imagine I take 2 people up, they come up, they shake hands. Next, 2 people up. Imagine that's 465 people, like group pairs standing right here. In other words, another way to ask this question is how many pairs can you choose from, different pairs can you choose from distinct, right? From a group of 31 people. And it's going to be 465. But again, what you're thinking is basically this. You're thinking, you know what? I wanted 2 people. So I want 31 times, right, 30. Oh, I cannot use Albert and Ben and Ben and Albert. That's the same thing. Let me divide by the 2 times the 1, right? Let me put 2 times 1 instead of just 2, so 2 factorial, right? 2 times 1. That's the idea. The 29 goes away. That's this right here. You see this right here? That's the 29 going away, like this stuff right here, because we don't want this, right? We do not. This and this. That was not present there, and that's what that correct cancellation is, because we want to get rid of it. So 29 factorial makes sense. That's why, because I'm talking about only a pair. Now, if I said how many trios of students, you would do 31, 30, 29, and then 3 times 2 times 1, and right? Cool, right? So that's the idea, everybody. And let me give you the final formula, combinations. So permutations, okay, permutations, the formula again, let me remind you. If you do, let's do n permute k, so permuting, you have n objects, and you're doing like k of them. How many permutations of that are there? And let's say without, so we're going to do without replacement. Without replacement, okay? So we're not going to replace anything. You do it once, like you have A, we're not going to do A again. We're going to have letters or words. Imagine you're talking about words that have no letters repeating. No letters, like for example, mother, all letters are different. Okay? Elephant has E's that are multiple. Cannot use the word elephant, for example. So this is going to be what? N factorial over, we already talked about it, n minus k factorial. And if you do choose and choose k, and we write it like this, and choose k, a lot of times you'll see this like in parentheses, and choose k, that symbol, you would have similarly n factorial, but over k factorial, n minus k factorial. You have to divide by that k factorial, that 3 factorial, that's 6, because those 6 are just really 1. That's the formula I really wanted you to get, is this right here. Everybody, I want you to remember this full formula. That's the whole point of this whole lesson. Is can you understand where in the world and what in the world does this even mean? And where does it come from? Okay? That's a full formula to know. All right, let's do this. Let's end the lesson here, and we'll continue further with probability and binomial expansion and all that in the next lesson. All right, thank you so much.